one, it's stopper. I put my cell for measurements. We got a water temperature, it was 15 degrees. You can see how it's jumping up. This is the time of measurement, and with this coil you can see, if we get a closer to the water chamber, we can see how the water creates hot water, and you can see that there the water hot is creating some the waves of the water that outflows from the heating coil. I put a temperature probe inside the coil. You can see that it's 68 degrees. Of course it's inside. See at the upper of a container, you can see that there is there's a steam. This is a steam. What I've changed in my circuit: the transformer is the same, the fan is the same, the ZVS driver is the same. I changed the transformer. The transformer is two secondaries of 35 volts, and power transformer is of 350 watts. This is a power supply for my fan, because it needs 24 volts, and we got our transformer 35. There is two heat sinks, as you can see. This is the second one, this is the second one, and they all goes to a ZVS driver. As you can see, the water temperature of the outside outflow from the my sonic boiler heating cell is almost 80 degrees. And as you can see, from the cell still outflow hot water, and you can see that there is a creation of the bubbles, small, very small bubbles. And with time the bubbles will come up more often. As you can see, there is 80 degrees, and it's going up. Now it's 84. It differs because this water gives the thermal energy to other water molecules outside the tube. Now we have 3 minutes, and as I told you in the last video, typical kettle has 2.5 kilowatts in my country. So I have 7 times smaller. Of course, I've changed also a water chamber because I wanted to show you more clearly what happens in the water tank, and the former one was dirty. As we can see, again at the temperature, it's 85, 86 degrees, so it's still climbing. Yes, it's very hot. It's very hot, and you can see how much steam is at the bottom of at the top of the water tank. Now we got 4 minutes, almost 5 minutes, and the temperature get closer to 90 degrees, and it still outflows. The more efficient way is when we isolate the chamber and we use bigger tubes that has more surface. As you can see now, it's 90 degrees, so it's closer to 100 degrees of the Celsius. The time is 5 minutes, 5.5 and a half. And yes, it's very hot. Of course, the temperature is a little. The temperature differs at the bottom and at the top, but with time, the water at the top will give back the energy to the bottom side. Now we got 91 degrees. Of course, when we increase the temperature inside the chamber, there are more losses to the environment. As I said, in this room there is 20.5 degrees of the Celsius. As you can see, the water bubbles go more often, and now it's almost 92 degrees of a Celsius. So the water is boiling, especially at the top, but we will go higher. There is almost 7 minutes, and you can see how often the bubble goes from the cell. And this is 92 degrees, even above. As I said, it differs. So yeah, I think that we could have a water for a tea or coffee with 9 minutes with 350 watts at 15 kilohertz frequency, that is AC. And now, of course, there goes steam from my chamber, and as you can see, look how strong the steam goes from the chamber. And now we have 93 degrees of the Celsius, and as you can see, the water is boiled with 9 minutes to 93 degrees. Yeah, it's hot. It's really hot.